As you can see, thinking about energy can get complicated pretty quickly. I often might have multiple systems in any given context. Those systems can have lots of objects in them, lots of forms of energy, and that energy can transform internally or it can be transferred externally to another system. To keep track of all of that, I'm going to introduce a new representation called an energy system diagram, which I will show off with an example. My example is a child pulls a sled up a snowy hill, picking up snowballs along the way. I'm going to start by trying to identify some systems. And for each system, I'm going to draw a large circle or oval to indicate what's in the system. I think I'm most interested in the child and the sled, so I'm going to make that system A, which I'll maybe label with a little A up there, and I'll draw a list of what's in the system. So the child and the sled, and everything in the sled seems to be what I might want to have in that system. Since the child is picking up snowballs along the way, I think it makes sense to have a system B. Maybe I'll draw that over here, which has like the hill and the snow. So those are the things that might be in system B here. And then I think I might be interested in thinking about how the earth interacts with these things. So I'll put the sort of rest of the earth in system C over here. And now I have a few systems of interest that I've kept track of. Again, I'm trying to construct this energy system diagram to track all the different forms of energy and how they're changing. So the next thing I'm going to do is to draw some little boxes inside of each large circle or oval to represent the different forms of energy that might be going on here. So I've got in system A, I've got a child and a sled. So I certainly could have some kinetic energy from the motion of those things. So I'll go ahead and put kinetic energy. I'll just lump the child and the sled together here. I think that's probably fine for right now. I also probably have some internal chemical potential energy that the child has. So I'll add a box to represent that. This would be chemical potential energy for the child. Well, I should probably go call this kinetic energy, not just kinetic. So I've got kinetic energy and some chemical potential energy. I also have a system over here, system C, which is the Earth. I think it might make sense to talk about some potential energy that the Earth has. Potential energy. That would probably be gravitational potential energy. In fact, let's go ahead and add that word here, gravitational potential energy. Looks like I ran out of space in my Earth box, which is okay. And then for the snow, I might think about them having some thermal energy in the snow. Thermal energy in the snow, which probably, of course, is very small since the snowballs are very cold. But it's nice to keep track of all the different forms of energy that I might have here. In fact, now that I'm looking at this, I probably would like to add some thermal energy for the child and the sled. So let me go ahead and add one last box here. All right, so now that I have all the different forms of energy written down in the boxes, what I am going to look for is possible changes in these energies as the context evolves. Those changes could be transformations of energy within a system, which I would represent with little arrows in between the boxes, or they could be transfer of energy from one system to another. So I want to try to keep track of both things. The first thing that occurs to me is that I'm going to have the child pulling the sled up the hill. The child is going to use some of their chemical potential energy, and it's going to become kinetic energy as the sled goes from being at rest at the bottom of the hill to moving as they are traveling up the slope. Eventually, however, as the child actually makes it up to the top of the hill, I am going to have changed all of that kinetic energy that the sled gained into gravitational potential energy in the Earth's system. So that is going to be both a transformation of energy from one form to another, but also a transfer of energy from one system to another. So I'm going to use a big arrow to represent the transfer of energy. And I should probably label some of these arrows here with the kind of thing that is happening, right? So this is kinetic to gravitational potential. Let's write this out in words. Kinetic to gravitational potential. It's also possible that there's a little bit of change to thermal energy in the child, both from the expenditure of the chemical potential energy and some transfer of kinetic energy into thermal energy. So it's possible that I might have a little bit of transfer going on here into thermal energy. And if you want, we could make those lines a little bit thinner to represent that those changes in energy might be a little bit smaller, or you could try to put numbers on there if you have any numbers for your problem. There we go. The last thing that I want to think about here is it says the child is picking up snowballs along the way. So there's going to be a potential transfer of energy here. As the child picks up the snowballs, some of the snow might melt. That's going to be a transfer of energy from the system with the child to the system with the snowball. So now I've got a transfer of energy from the child to the snowballs. And it's also possible here that I have, because the snow is also going to change elevation, I'll get farther away from the surface of the earth. I might have a little tiny transfer of energy from the snowballs to the gravitational potential energy of the earth. Although it's also possible I could view this from the perspective of adding the snowballs into the system with the child, and then that would just get lumped into the transfer of energy that I already have for kinetic to gravitational potential. So here's an example of an energy system diagram. You can draw these for just about any system or set of systems that you want to track the different changes in energy. As you go forward, you can quantify how much energy is being transferred or transformed in any of these arrows, and it can really help support the calculations that you're doing.